question for you. Let's start right here up front, please.
Hello, I'm Andrew, and I'm a computer science student here. I'd like to thank you for coming. It's certainly a privilege to hear you talk. I'm interested in your work in education, particularly your investments in the Khan Academy, which I'd personally like to thank you for saving me last year in linear algebra. What is being done currently to bring this technology to the mainstream education, where you have, like you were saying, an ability to quantitatively evaluate students, and if there really isn't even a need for a teacher role anymore with games and stuff for the internet for education? Thank you.
Yeah, as you go from kindergarten up to college, certainly the need for adult supervision hopefully goes down somewhat. But remember, education to some degree is about motivation. I mean, if you want to learn physics and you're highly motivated, Feynman wrote a book. It's called The Feynman Lectures on Physics. Read it. You don't need a university. And if you're that motivated that you can sit and read that thing, wow, that's, theory of algorithms, just read Knuth. And by the way, do the problem sets while you're at it. So education is not about the unique availability of information. It's about some pureeing of the information into a form that the student chooses to ingest it. And so how do you create that framework? Well, I think there'll always be a teacher to some degree, but the place that's most replaceable is in the case of the lecture. And so I think the answer to your question is to take full advantage, you can take slight advantage of Khan at all, just as a supplement. Mom, I was confused about this. Mom doesn't know. Mom points you to Khan. You watch the thing, try some things out, and it helps. It's a supplement. But the big impact of Khan so far is where the teacher's been willing to flip the classroom. And what's meant by that is that there are no lectures done in the classroom. You assign the lectures, which are watching the Khan videos, maybe 2 or 3 a night, and then you do the basic problem sets associated with those lectures. When you come in that next day, the teacher sees who watched those lectures and who didn't, and sees how well people did on those problems. And so that teacher can then divide the class up into groups and do problems that develop that knowledge, put that knowledge in context, make the knowledge interesting. Why would you want to know about that, which is not the part that Khan is focused on? Actually, we have other people on the web looking at, if I want to do nursing, why should I learn math? If I want to do construction, why should I learn math? And complementing that with the Khan stuff. So we have about 20 schools now that have redesigned the entire classroom experience around those Khan lectures. There's a charter school called Rocketship that's completely redesigned around using online curriculum. And so within a year, we'll have the results from that. Only one school did that last year, Los Altos, 5th grade, and the numbers appear to be very, very strong. Now, the acid test for education is inner city schools, where the environment, the motivation is the weakest, and that's why half the schools we're trying out right now are inner city schools.
Alex Darling, biochemistry major. One of our professors, my math professor, is big into education in third world countries, and he's written a couple articles including stuff about computer science and whether or not it's necessary. I was wondering, what are your opinions on computer science in education, starting even in elementary school, and whether that's a good idea?
Get this right.
Well, I think the computers is a great tool, and you should be using it as much as you can. If by computer science, we mean understanding queuing theory and, hashing and, how you do database indexes, I'm not sure where in the curriculum that should come in. I do think being able to write a program, if you think you understand, say, prime numbers, the idea that you can express that by writing, say, a SIB algorithm, I think that's a very interesting test of whether I know prime numbers or not. But it's hard to say anything is necessary in the curriculum. I mean, can we say that geometry is necessary in the curriculum? No, it's probably not. People don't get to use arc signs that much once they graduate. there's certainly a level of complex symbolic thinking that is valuable to be exposed to. You know, personally, I might put statistics in instead of geometry. I'd put statistics certainly before calculus. I'd have more people take statistics and calculus. Where computer science belongs in that hierarchy, I don't know.
So here's what I think our pitch would be
Yeah.
in computer science, and that is there's this notion originally from Jeanette Wing of computational thinking. And computational thinking is a lot of the things you've described. It's algorithmic expression, it's problem decomposition, it's stepwise fault isolation, what we call debugging, it's modeling. There are a set of things like this that need to be part of everyone's bag of tricks. And writing a program is perhaps a way to learn and exercise a set of those skills. But the critical thing to me is that this computational thinking is something that every student needs, which is again different than understanding hash functions.
No, I think that's right. I do find that people who have computer science backgrounds, when given a problem from another domain, the idea that they take the system and they look at the size of various elements, they look at the rate limiting steps for various elements, you know, and they can say, okay, we need to optimize here. That type of thinking is like, yeah. And, you know, what other domain gives you that type of systems thinking? Maybe some parts of science and engineering, but the basic notion of what's an algorithm and that many systems and societies are basically poorly designed algorithms, I think that's very worthwhile.